Take your periodic table out of the plastic cover. You'll be taking notes on it during the video. If you don't have one, make sure to move the attachment on the assignment page into Notability and take notes on that.
Can you see the grey diagonal band that splits the periodic table into two parts?
Pause here and draw the step line on your periodic table. Notice that it goes across under the B and then down across like steps from there.
This divides the elements into metals on the left and nonmetals on the right.
Pause again and label your periodic table. I used the Post-it notes from my chemistry kit.
What is a metal? Here's a few: titanium, iron, chromium, aluminium, silver, and gold, with the atomic numbers above the symbols. Have you noticed that these metals are shiny and solid? They all are, well, except for liquid mercury.
Pause and add that to your Post-it note for metals. Continue to pause and add notes as you learn more characteristics.
Metals also conduct electricity and heat. Here, the different metals are connected to an electrical circuit. If the bulb lights up, it means that the thing is an electrical conductor. They all are. Metals are also malleable, which means that if you belt them with a hammer, they'll flatten into a thinner shape. Here you can see that aluminium has three metallic properties. It's already been flattened into a thin sheet, it's shiny, and it conducts electricity. We looked at aluminium, titanium, chromium, iron, silver and gold, all to the left of the diagonal, and saw that they all have metallic properties. What about nonmetals to the right-hand side of the diagonal? They're the opposite. Most nonmetal elements are liquids or gases, but there are a few solids, and these can be more easily tested. Sulfur and selenium are showing that they don't conduct electricity. Can you see that the bulb doesn't light up? And if you hit this carbon with a hammer, it smashes into bits. This is called being brittle. It's the opposite of being malleable.
Pause here to make sure you got all those characteristics written down.
Let's use the periodic table to predict whether an element would be a metal or a nonmetal.
How about osmium, number 76? It's located to the left of the step line. What properties do you think it would have? It's a shiny metal. Is that what you guessed?
How about iodine?
What properties do you think it would have? It's a bit harder to predict because there's more variety in the nonmetals. How about yttrium? Would it be shiny or dull? Would it conduct or no? Would it be malleable or brittle? How about phosphorus? It's to the right of the step line. Looks pretty dull and brittle to me, and it doesn't conduct.
What about the elements inside the diagonal band? Let's take a look at silicon. It looks shiny like a metal, but if you whack it with a hammer, it breaks into bits. So it's brittle like a non-metal. And the dull glow of the bulb tells us that it conducts electricity more than a non-metal, but not as much as a metal. And this gives it the name of semiconductor. These elements are also called semi-metals because they have properties that are in between metals and nonmetals.
Pause here and copy these notes.
Are they more metal or non-metal elements? Metals! But that doesn't mean they're more abundant, because in the Earth's crust, there are more oxygen and silicon atoms than the rest combined. And the universe as a whole is mostly hydrogen.
In fact, hydrogen is special in lots of ways. It's to the left of the diagonal, but it's not a metal. The truth is, hydrogen doesn't belong to any group. Some periodic tables even put it on its own to show this. Just remember, hydrogen is special.